So, what is actually happening in Malaysia lately? We all know it's getting incredibly hot, and we face this intense, humid, tropical climate all year round. But in our urban area, the heat is even worse because of the urban heat island effect. A huge part of the problem lies right above our head. Most of our residential, commercial, and industrial buildings are built using a standard material. And under our blazing sun, this material acts as highly efficient thermal conductor. They literally absorb up to 85% of solar radiation and transfer that heat directly into our building. This massive heat transfer creates a really challenging cycle because our indoor space are baking hot. We have no choice but to blaze our air conditioning to stay comfortable. This drives up household electricity bills, put massive pressure on Malaysia's national power grid, and increases carbon emission from fossil fuel power plants. On top of that, our roofs are taking a beating. The constant fluctuation between extreme daytime heat and heavy tropical rainfall causes roofing material to expand and contract. Over time, this leads to structural deterioration, cracks, and annoying water leaks, which mean high maintenance costs for building owners. And how do we solve this heat problem without consuming even more electricity? The answer is a smart passive cooling technology, which is cool roof coatings. These are specialized liquid applied chemical membranes that we can paint directly onto existing rooftop. Instead of absorbing heat, they act like a mirror to bounce solar and UV wavelength away from the building. It is a highly practical, affordable way to renovate existing buildings. Not only does it keep the indoor cooler and lower energy bills, but it also physically protects the roof structure from weathering, cracks, and leaks. Now that we understand the big problem with tropical heat in Malaysia, let's dive into the core engineering behind the solution. We will look at a technical overview, which focusing on the simple physics of how cool roof coating block heat. So, how does this actually work? Research shows that nearly 1/3 of all heat that enters a building flows directly through the roof structure. This is why roof insulation is a major civil engineering priority. Unlike normal decorative paint, a cool roof coating is engineered to handle thermal energy using two key physics principles. First, we have solar reflectance. Think of this like a mirror. It bounces a massive percentage of the sun visible, infrared and ultraviolet wavelength away before the rooftop can absorb them. Second, we have the thermal emittance. Even under extreme sunlight, a tiny amount of heat will still get trapped. Thermal emittance is the material that capacity to quickly and efficiently release that trapped heat, radiating it back out into the sky instead of letting it conduct downwards through the ceiling and into our living space. To achieve this high performance level, the chemistry of the coating relies on two specific functional ingredients. The first one is titanium dioxide. This is a powerful white pigment that scatters sunlight, providing that strong initial brightness needed to block solar radiation. The second one is the hollow glass microsphere. These are microscopic spherical particles embedded in the paint layer. They create a tiny thermal barrier that dramatically reduce the heat conductivity of the coating while making it much more durable.
So I will be talking about application and installation of cooling. Now, a lot of people love to use cooling roof because it can provide protection from heating, which makes it very suitable for residential and industrial. Cooling rooftops also can help all the workers because it can reduce high temperature and increase the productivity in the industrial. It can also provide them to work in place set in very comfortable area without feeling any stuffy. It is also can improve indoor comfort for all residential and can reduce their usage of air conditioning. This method can lower the homeowner electricity consumption and saving their electricity bills. So these are the types of application cooling rooftop. So there are three applications, which is liquid coatings and paints, multi-layer rooftop, and commercial single-ply membranes. So the benefits of liquid coating and paints, it is to reduce the urban heat island in any land surface or urban area, and also to reduce air temperature. For multi-layer roof system, it is to reduce the indoor heat. And now I will be talking about material evaluation on cooling rooftop. Material evaluation on cooling rooftop is to determine how they reflect the heat and cool on a building, whether it's large or small. For example, their reflection is solar reflection, thermal emissivity, and UV light. It is also depends how much it will affect the residential for using different material that absorb light. Even though using such materials are benefits, but it also has its own cons too. For the insulated metal sheet, it can reduce noises and is very lightweight, but it can absorb heat if the layer is so thin between the roof. The best use for insulated metal sheet is at a warehouse. So these are the pros and cons of material evaluation types. So there are three material evaluation, which is radiative cooling coatings, green roofs, and insulated metal sheets. For the green roof is for the aesthetic for the residential place and can be also cheap, but the capability to hold heavy items for the green roof are very not recommended. So the best use for green roof is at a park or any urban spaces. Now for the radiative cooling coatings, the pros are it can reduce temperature due to hot weather and it is energy saving, but radiative cooling coatings can be also expensive and can be overcooling when it comes to any cool weather. It is best used in metal roof and can be applied in any sunny places but not any cool places.
Today I will be presenting the thermal performance and energy saving of the cool roof coating. I will explain the comparison between conventional roof and cool roof for the thermal performance analysis. For the first parameter, it is the solar reflectance. The conventional roof have low solar reflectance while the cool roof have a high solar reflectance. And according to Wang and the other researcher, on 2024, the solar reflectance increases by 0.24 to 0.37 depending on the roof color. This means more sunlight is reflected away instead of being absorbed. The second parameter is thermal emittance. Thermal emittance refers to a roof ability to release absorbed heat back into the atmosphere. The cool roof coating have a much higher thermal emittance than the conventional roof, allowing them to cool down faster and reduce heat transfer into the building. As for the roof surface temperature, studies show that cool roof coating can reduce roof surface temperature by 9.2 to 14 degrees Celsius under a strong sunlight. This significant reduction keeps the building cooler throughout the day. Next is cooling energy consumption. Since less heat enters the building, there is less need for air conditioning. Research saw that cooling energy consumption can be reduced by approximately 3.9% to 5.5%. This lowers the electricity usage and operating costs. For countries like Malaysia, where temperature remains high throughout the year, these can provide significant long-term energy savings. This is also supported by the report, which explained that reduced heat transfer improve the indoor comfort while decreasing reliance on the mechanical cooling. Lastly, the final parameter is the indoor thermal comfort. Because less heat enter the building, occupants experience a cooler and more comfortable indoor environment. According to Yu and the other researcher on 2018, cool roof coating improve occupants' comfort by reducing heat transfer to the roof. This is especially beneficial in homes, schools, offices, and factories where comfortable indoor temperature can improve health, productivity, and overall well-being. Now, let's move on to the energy saving analysis. Research has shown that cool roof coating reduces cooling energy use by 3.9% to 5.5%, while annual energy saving can reach 5.8%. The main reason is their high solar reflectance, which reflect sunlight and prevent excessive heat from entering the building. As a result, buildings require less air conditioning, reducing electricity consumption and greenhouse gas emission. These benefits are especially important in Malaysia because cooling is needed almost all year due to our tropical climate.
Next, I will be presenting the benefits of the innovation and material comparison. So the first benefits is reducing the energy consumption. As we are aware of, the average temperature in Malaysia is between 33 to 33 degrees Celsius. However, during the mid-year, the temperature is between 30 to 34 degrees Celsius. This shows that the reliance on air conditioning system is very high to circulate the heat, thus increasing the energy consumption. The cool roof technologies can significantly enhance the energy efficiency of every building, especially during the middle of the year where the temperature is on its peak. Through the reflection of infrared and UV radiation, the indoor temperature in a building will be reduced, thus helps to lower the electricity consumption. By minimizing the cost of air conditioning system in a building, the peak energy usage, especially during June until July, will be reduced as well as the risk of power outages will be decreased. Thus, for every house owners, the electricity bills and reliance on fossil fuel power energy sources will be lowered. Next, we are looking at how cool roof coatings protects the environment. First, it mitigates the urban heat island effect. This means it stops big cities from getting too trapped with hot air and feeling like an oven. Second, it reflects sunlight and lowers the ambient temperature by several degrees. Instead of keeping the heat, it bounces the sunlight away to cool down the air outside. Third, it absorbs less heat compared to traditional roofing materials such as concrete. This means the roof stays much cooler during the day than a normal hard stone roof would. Fourth, it provides additional thermal insulations and reduces fluctuations in temperature. This means it blocks outside heat from getting into the building while keeping the indoor air temperature steady and comfortable. Finally, it mitigates climate change effects in Malaysia by keeping our surrounding tropical climate cooler. It helps protect nature and reduces the harmful impacts of global warming. Then we are looking at how energy management affects the economy. First, Malaysia's government passed the Energy Efficiency and Conservation Act, or known as EDCA. This means the government made an official law to ensure people stop wasting power. Second, this act focuses on the promotion of energy efficiency in the building sector. This means creating special rules to help large factories, offices, and shops use much less power every single day. Finally, following this law can reduce a building's electricity bills by up to 25% with the assumption of the energy prices remain stable. This allows large businesses to keep a quarter of the money they. Then we are looking at how energy management affects the economy. First, Malaysia's government passed the Energy Efficiency and Conservation Act, or known as EDCA. This means the government made an official law to ensure people stop wasting power. Second, this act focuses on the promotion of energy efficiency in the building sector. This means creating special rules to help large factories, offices, and shops use much less power every single day. Finally, following this law can reduce a building's electricity bills by up to 25% with the assumption of the energy prices remain stable. This allows large businesses to keep a quarter of the money they normally spend on power, and the result is they save a lot of money. Next is the societal impacts of cool roof coatings. First, this technology serves to improve the public health. Ensuring a safe indoor environment prevents a various short-term and long-term illnesses. Second, it improves the indoor air quality while lowering the carbon emissions. This creates a stable working climate and protects the occupants inside from the respiratory diseases. Third, the mechanism depends on solar reflectance to reduce the humidity in the building. By reflecting the solar heat, it prevents high moisture levels and stops the growth of fungi on the furnishings inside. Finally, I think we can all agree that it functions to improve the thermal comforts. In the result, this can enhance the human well-being by allowing the body to shed heat naturally. Then we're going to talk about the comparison between the existing construction materials. For the first aspect, heat management mechanism. Concrete absorbs heat during the day and stores it. For the night, it will radiate the heat downward into the house. As for the timber is a better thermal insulator compared to concrete and steel. For the steel absorbs heat and allows instant heat penetration into the building. As for the cool roof coatings, they reflect the solar and UV radiation and prevents the penetration of heat into the building. Next aspect is the solar reflectance. As we can see here, steel has the lowest, meanwhile, cool roof coating has the highest solar reflectance. For concrete and timber, they have low and moderate to low solar reflectance respectively. As for the surface temperature, concrete is the highest and cool roof coating is the lowest. As for the steel, it is extremely high, which ranges between 60 degrees Celsius to 70 degrees Celsius. For the timber, Timber slowly heats up to 50 degrees Celsius under prolonged sunlight. As for the aspect of the durability, we can see here that the cool coating has the lowest lifespan. It can only last up to 20 years. For the concrete, has the highest lifespan, which is up to 100 years. As for the timbers, it can only last up to 35 years unless it does not undergo the treatments. As for the steel, it can only last for 25 years. Next is the aspect of the cost. We can see here that timber has the lowest cost, meanwhile the cold coating has the highest cost. As for the concrete, it is lower than the steel cost. Now this market analysis details the potential application of heat reflective coatings. First, the industry will evolve towards smart multifunctional coatings, and these advanced materials do more than prevent the heat because they can also self-clean. Second, the technology achieves better performance by using the infrared reflective nanopigments and fast-chain microcapsules. These special tiny ingredients act like advanced shields to stop heat much better than a regular pen would. Third, this system increases the lifetime durability for more than 20 years, which means the protective roof layer can last for a very long time without it breaking down. Finally, we all agree that these combined impacts form a major selling point in the industrial market. Factories and large companies want to buy this because it saves money and lasts for decades. Here is the evaluation of how the cool roof coatings contribute to thermal comfort. First, the coating can be applied on various building types that includes residential houses, commercial warehouses, and factories. It serves to protect the different kinds of home and workplaces from heat. Second, the product is applied on surfaces like metal or concrete. Regular metal and concrete roofs normally absorb a lot of hot sunlight. This special paint counteracts the solar rays to lower the indoor temperature. Thirdly, this technology will become one of the necessities for all the buildings and households in the future. The global environment is changing and becoming much warmer. Therefore, every building will naturally require this shield to stay safe and comfortable. So how does it being used? This part examines the operational application of fire filter coatings. Large-scale manufacturing plants like Nippon Paint Malaysia. So how does it being used? This part examines the operational application of fire filter coatings. Large-scale manufacturing plants like Nippon Paint Malaysia use these systems. A prominent example is the solar roof product line. First, it operates as a heat-resistant and water-based coating. This liquid paint acts like a protective shield against intense sun rays. Second, it serves to lower the temperature of the roof surface by up to 5 degrees Celsius. It blocks UV rays so the actual building structure stays much cooler. Third, it functions to enhance indoor comfort and create a more energy efficient environments. Occupants inside will feel much better inside and the building requires less electrical cooling power. Fourth, the system provides a total of 10 years of continuous protection. It shields the building for a full decade without wearing down. Lastly, the material is suitable for the clay roof tiles, concrete roof tiles, and metal roofs. This high level of versatility allows it to work effectively on almost any house and factory roof.
Next, I will present the research trend on cool roof coating. Next are the current research trends. Research has shifted from improving the performance of individual building to addressing the larger issue of urban heat island, or we call it UHI effect. Researchers now combine field experiments with computer simulation to evaluate cool roof performance. New materials are also being developed using cool color pigment, radiative cooling coating, thermochromic coating, and self-cleaning surface. However, one of the major challenges is Durability. Thus, ultraviolet exposure, pollution, and weathering can reduce the coating effectiveness over time. The current development focuses on integrating cool roof coating with other sustainable building technology. For example, they are now combined with photovoltaic panel, which we call it PV, combined with green roof and used alongside with high performance insulation, and then it's also support passive ventilation system. Researchers also evaluate the performance using indicators such as solar reflectance (SR), thermal emittance (TE), solar reflectance index (SRI). More studies are now being conducted under Malaysia's tropical climate to better understand their long-term performance. Finally, let's look at the future prospect. Future research aims to develop intelligent and adaptive roof coating that can automatically respond to environmental changes. Examples include the thermochromic material, the radiative cooling technology, nanotechnology-based coating, and researchers are also beginning to use artificial intelligence and machine learning to predict coating performance, select suitable material, and support sustainable urban planning. This innovation will make cool roof coating more durable, energy efficient, and environmental friendly in the future.
Now we have reached the final part of our presentation, the conclusion. Let's summarize the key takeaway of our project and look at why cool roof coatings are such a valuable solution for Malaysia's future. Cool roof coating are a fantastic and simple solution for Malaysia hot tropical weather because they keep house much cooler without needing to change the roof structure. And they act like a protective shield on your home, dropping the roof surface temperature by up to 14 degrees Celsius and naturally lowering the heat inside. Because your house stays cooler on its own, you won't have to turn to run the air conditioner as hard, which directly cuts down your monthly electricity bills. On top of that, it will save your money, and the coating helps to prevent roof weathering, cracks, and nasty water leaks during the heavy rain, while also doing good for the environment by punching the hot sun away to cool down the whole neighborhood.